So this is the hydrocell sealless diaphragm pump. And it's a 90 horsepower, 91 fluid horsepower plunger pump, but it's a sealless design. So if you notice in here, we don't have any packing or plungers that need maintenance. There's no area to get rid of the waste because plungers always need to be lubricated. The packing needs to be maintained. So there's less maintenance on this type of pump. There's the plungers and the packing and the cylinders are not in the process fluid, so they're not a maintenance item anymore. So there's less cost for the monthly operation of this type of pump.
So the fluid is in contact with the diaphragm, right?
Just on top of the diaphragm.
Okay. This diaphragm is being powered with this system.
Exactly.
Okay.
The same fluid that lubricates the bearings drives the diaphragm hydraulically, but they're not connected mechanically. Okay, so the diaphragm is completely separate. It's a balanced diaphragm type of pump. So this is a 3,000 psi pump, and you could be operating at 500 psi, 10 psi, or 3,000. The diaphragm only sees 5 psi differential pressure. It's not under stress.
Okay.
It's only a barrier, and then it also, we make it in different materials for chemical resistance, depending upon if you're pumping sour fluid.
So the fluid will be seeing the inside of the diaphragm. I mean, that is the area where the fluid
yes,
is contact.
yeah. So when you're considering what you're pumping, we would choose the right diaphragm or the right fluid head material. This is nickel aluminum bronze. We also make it in 316 stainless. So if you're running a little sour, that kind of thing.
Okay.
So if you the type of maintenance that needs to be done on this pump that is typical, the valves, the discharge valves, the suction valves can all be maintained without disturbing the plumbing. So routine maintenance, an operator, someone could come up to the site, and to get into a discharge valve, they're accessed through the top here, and you remove these plates, and the discharge valves come out. And this comes in a cartridge valve. This is heat-treated stainless. We also make it in tungsten carbide. So if there's a lot of sand in the well, particulates, we can beef up the abrasion resistance of our valves. So from a replacement standpoint, very simple to do, very straightforward, and that's typical of any pump. You're going to have valves to work on, but there's no real special equipment you need. So the discharge valves can be accessed from here, and then the suction valves, you would remove these bolts, and then you would pull it off this way. If you need to get farther back in the pump to access the diaphragms, we offer, in our toolkit, we offer these basically precision studs that we have called stud extenders, and these would be mounted in the 4 outer studs.
Okay.
So once you take your head bolts off, these can go on, and then you remove your bolts, your head bolts. These bolts also have to be loosened. They go back into the diaphragm plate for strength. So there, you need to get into the diaphragms, you pull it out like this. So here, now we have a situation where you can see the diaphragms are exposed. You can inspect the diaphragms from here. If you feel that a diaphragm, it's not a wear item. It's not something that you need to do on a PM. But they can become under a chemical attack. It could be any kind of additive that might be going in the well, rust inhibitor or what have you. So you can inspect them from here. If they need replacement, there's just 2 screws here. Pull it off, put on a new one. And what happens is the diaphragm too from here also, you see the outer lip acts as an O-ring seal. So it allows you to pull this off without having to put any new O-rings in it. So the diaphragm is also the seal, and it also does the work. So this is a 2.5 inch stroke pump. So for every 2.5 inches, the diaphragm moves 3/4 of an inch displacement. Yeah. This one runs basically about a barrel a minute, 45 gallons a minute.
And how long this lasts usually?
The diaphragms?
I mean, in a hostile environment.
In a hostile environment, I would replace them on a yearly basis. And it's usually not, it could be chemical attack, but what happens is if you get a lot of abrasives, which we do, the wells get a lot of sand, and then you get abrasiveness, just replace them. They're not under stress, but if they get cut.
Is it very expensive?
No, they're not expensive.
It is like a consumable.
Yeah, it's a consumable.
Nothing,
everything.
Nothing, so special or making it more expensive.
No, it's not more expensive at all. So what we're trying to do here is we have a pump that's easier to work on, zero emissions. So if there's any kind of pumping light hydrocarbons, we don't have to put any kind of gas containment area on the stuffing box.
Right. And this can hold 3,000 psi.
This pump is 3,000. We have another option that goes up to 5,000. It depends upon your well conditions.
Well conditions.
Yep. And then we have a lot of smaller pumps too that are up to a quintuplex, and smaller flows for if you have some smaller producing wells that can be used. And the jet pumps also, they'll pair that with their program to get optimize the surface pump to what's down there.
So, what make it more energy efficient? Is this more energy efficient?
No, it's not.
It is.
It's not more energy efficient.
Okay.
We have the same type of energy requirements as another type of pump.
Okay.
As far as mechanically, we're not any more energy efficient. Volumetric efficiency is about the same.
Okay. But the main advantage is this is more environmental friendly and then it's a consumable system.
Exactly, and it's easier to work on it, and you don't have the usual maintenance cost of the packing the plungers, or having to get rid of the waste because they have to leak. So then you have to have some way of disposing of the drip waste.
And what about the overall cost compared to a conventional pumping system?
Very competitive. Very competitive. Yeah. We're not the high guy. We're not the low guy.
Okay.
On the block for that kind of thing. So.
And what about the maintenance on the other side?
The maintenance on the other side will be typical. We have a forged crank, and in our crank, for our connecting rods, we have replaceable Babbitt shell bearings.
Okay.
So that would be somewhat typical of a similar type of pump.
Okay. So like annual maintenance, the PM schedules, etc.
Yep, and that's put together based upon hours per day and your operating conditions. We have a chart on how often to change the oil.
Okay.
One of the nice things about this design versus many typical plunger pumps is that the crank bearing doesn't have to be shimmed.
Okay.
We use spherical roller bearings, so this crank can be removed within a period of anywhere from 3 to 5 hours, depending upon the condition of the pump.
Okay.
And you go back, and the installation is much easier. No dial indicators on the shaft. You put it in, and our plungers are self-aligning into the cylinders.
Okay.
And the reason we can do that is because we don't have any packing in there where we have to worry about even running with the packing. Otherwise, the plunger gets cocked, packing leaks.
Right.
Our plungers run in a ductile iron cylinder with a hardened steel, so two dissimilar metals that's always lubricated with the oil in the crank.
Okay. And this is the same oil here as well, right?
It is. Yep.
Okay.
And it's a typical whatever. For many applications, 10W30, cold synthetics can be used. No special type of lubricating oil in the back.
Okay.
Yep, something that can be picked up locally. So after you're done, if you wanted to get farther in the back of the pump, we can do that.
Okay.
We'll remove some of this here. So what would happen if you wanted to get in the back and check the operation of what's going on behind the diaphragm? It's a very it's a robust and simple design, but these two bolts would have to be loosened and removed, and then at this point you can in the field get back, and here we show from this angle you can see our cylinders. This is the ductile iron Durabar type cylinder. We have two-way checks here, so if some of the oil gets foamed and back and we get some entrained air, the air will automatically go out, and then once you get viscous oil, it closes. So these will hold up against whatever pressures behind the diaphragm.
Okay.
Here's our plungers. Very similar to any other type of pump. They are floating though, which is nice.
Okay.
And how we do that on our crosshead, coming through the crosshead to the plunger, we use spring-loaded Bellevue washers. And so it allows, once you assemble this back together, the plungers find their true line. it's easier to work on that way. So once you're in the back, this is very similar to anything else as far as maintenance and that type of thing. But this gives you a kind of a good idea of what's going on behind here to make it a sealless type pump. One of the things too that we tested, the pump can run dry. So if your tank runs real low, and by some reason it happens, there won't be any
because it is a diaphragm.
Yeah, and no damage to the pump because we're not using whatever you're pumping as a lubricant. So it can run dry, you fill the tank, you start it up, and away it goes. So, and we also run a closed inlet test on the pump where we actually shut the suction off every 20 seconds and also to max pressure. So this pump can run, somebody clogs a strainer, it happens, or closes a valve on the suction side. If you starve the pump, once you fix the obstruction and get fluid to the pump, it'll take off. It won't damage the pump on a starved suction.